Good morning, everybody. Welcome to day 2 and our final day of the AWS Public Sector Summit. Thanks for kicking it off with us this morning. Just a few reminders. The emergency exit for this room looks like it's only in the back. Please don't go in the elevators in the event of the emergency. Please turn off your cell phones. We are recording all of these sessions. They will be available online, the slides and the recordings, about 2 to 4 weeks after. And at this point, I'll turn it over to our esteemed panel who will tell us about leveraging machine learning for forecasting and governance. Thank you so much.
Good morning, everyone. Appreciate coming out for the early morning 9 a.m. For those of you that were here yesterday, really felt like this is probably one of the best summits that I've ever been to. So what we would like to do today is just walk through lots and lots of our customers are asking about machine learning. And ECS is one of the few companies in the world to hold the machine learning competency. So we thought it'd be an interesting topic, and our panel is going to walk through just a little bit more information and practical use cases, which we think are always good. Our overall agenda is we're going to walk through just a very brief ECS introduction, talk about some common challenges that we're hearing from customers, really highlight the AWS ML solutions, which is really the most innovative platform for machine learning. Talk a little bit about some solutions we've developed, and then some of the value and benefits, and then overall just lessons learned. So we want to make it very practical, and then we'll leave a little bit of time for some Q&A. So any questions you might have on machine learning, this panel is one of the most experienced in the country, so we thought give you that opportunity to talk at that point. Just as far as speakers, Ross Serino is our Director of Cloud Transformation. We'll talk about some of the use cases. Kiran Bakshi will talk about some of that great platform that AWS offers. Imran's going to go through some of those use cases, and I'm just going to give a little bit of an overview of who your ECS is. So high level, ECS is a leading provider really focused on the AWS platform, also on cybersecurity and software engineering. We are out of the DC area, so if you're local, this is kind of our DC metros where we're focused, but also nationally, around 750 million in revenue, so big enough to handle almost any of the challenges you might be coming up with, and around 2,500 employees, and also one of the top workplaces in the U.S. So if you happen to be looking for any kind of employment opportunities, please also come see us. In terms of our AWS expertise, we are a premier consulting company. That's the highest level of partnership for AWS. And really, in addition to the machine learning, managed services are a very big part of what we do. So what we find is once customers develop these great solutions that we can assist with, a lot of times they're looking for companies to manage them, and that's an area that we've really, over the last 5 years, put a lot of energy into, so as an audited MSP. And then also DevOps competencies and the Microsoft workload competencies. This will walk through some of those a little bit, but I think the focus here is we've been doing AWS since roughly 2010 and watched as it's developed, watched as customers have increased their usage, and across the different challenges you might be facing, ECS is one of the leading providers in the country. So we'll focus today a little bit on machine learning, but in general, across all of the different workloads you might be looking to move to the cloud, the AWS cloud, ECS has one of the most experienced teams in the country. This machine learning competency was something that came out last year. We were very focused on it. We had been doing a lot of machine learning specifically around the Defense Department, which has some pretty interesting use cases specifically around taking video data and transforming that into more intelligence. And so if you think about some of the amount of drone video information out there, that was really where we had initially focused, and since then have been doing a variety of different workloads for customers across the country. Turn it over to Imran, who's going to walk through some of the challenges we've been seeing with our customers.
Thank you, John. Oops. Hey, good morning, everyone. Is everybody able to hear me in the back? Okay, great. So one of the things is I'm assuming that most of the people here, you have at least one or more workloads in AWS. And as part of that, you've got the pleasure of looking at your bill. And in your experience and in our experience with many of our customers that we have been talking to, some of the questions that often come up is, are there any, how's my bill so high? Can I get some details behind my bill? And if you have looked at the detailed billing file as AWS moved from an hourly unit charge to minutes to seconds, the volume of that number of lines in your detailed billing file keeps on increasing. So what are the details behind that? Are there any patterns that I can see that will help me improve my cost? Am I overspending, underspending, and all that? So all of these things, really boil down to is how am I managing the cost of my utilization of AWS or my cloud environment? And since it gives me opportunity to innovate, it's an elastic environment. I can start things out at I don't have in my provisioning is like in seconds. The cost can be pretty big. How do I manage that? So that are some of the biggest challenges about cost. And then once I'm started utilizing those assets, are these assets necessary? Am I overspending? Am I underspending? Where can I fine tune where my cost is manageable and even more importantly, predictable from a budgeting standpoint? And even when I start using these assets, are they compliant with my organizational policies from a security standpoint, governance standpoint? Is it allowing me to keep my data safe and secure? Are there any vulnerabilities in the assets that I'm using? Are there any gaps which would pose a risk to the data that I'm storing in the cloud environment? So for some of these cost-related questions and some of the other governance-related questions, is there an easy button for that? And this is where ECS, with our experience in many of the customers over the last 7 or 8 years that we have been working in these multiple cloud environments, we have come up with a strategy to help solve not some of these cost-related and other issues that the customers keep bringing to us. And what ECS has developed is what we call a common cloud framework. And it's a set of policies and tools and automated scripts that can help solve our customers' problems as they start adopting cloud, as they operationalize their cloud, and as they want to optimize their cloud usage and in the cloud environments. Our cloud platform is this common cloud platform or framework is we have broken it down along 5 different axes because that's where the most of the categories that customers are interested in. As Ross and John, Kiran, we were talking this morning, we were talking to one of our a very large telecommunication customer yesterday, and they said, yes, we have somebody managing our accounts for us, and we have got our DevOps under control, but operationally, we are not sure how we're going to manage our data, how we're going to do our patching. So this framework not only helps us optimize our customers' environment, it's a starting point to identify what kind of issues they are running into and help us customize and focus this platform specific to those organizational and customer needs. So as I said, these, I'm going to go back, sorry. So it's a little hard to read on the here. So anyway, so for example, in terms of accounts management, right? Do you want to manage your accounts? Some people like to manage it by, they break their accounts by environments. Some people like to break it down by departments. Some people like to break it down by workloads. So depending on your organizational policies, we provide automated tools for monitoring, establishing, deploying these accounts, and then making sure leveraging AWS's best practices and AWS services like organizations so that policies can flow down from top-level accounts to sub-accounts and linked accounts as well. Similarly, for migration, we have developed tools where we can discover your on-prem environment, then help you build a secure and NIST 853 compliant infrastructure, and then help migrate those on-prem workloads into your AWS compliant cloud in an automated and structured manner. Since we were talking about cost, I just want to focus a little bit more because our discussion today is a little bit more focused on cost. So what is our cost control approach? As you start migrating and adopting cloud and taking your workloads into the cloud, you start seeing what kind of assets you're using, how you're using compute, how you're using storage, how you're using any of the elastic services along with that. And that gives us insights into what kind of patterns how do you want to govern your entire environment to help us optimize. And that insight and the governance model helps us optimize your cloud savings and optimization in the cloud. We can identify things like, are you using any underutilized EC2 instances? Are there EC2 instances much bigger than your needs are? Are there, you have purchased reserve instance capacity, but your coverage on your reserve instances capacity is much lower than it should be? Are you leaving some of the money on the table? Can you leverage life cycle policies on storage so you're not paying for the top end storage, but you can move that into Glacier or things like that. So what it does, it helps us by enhancing our the forecasting and prediction. We can taking the insights into your cloud usage. We can identify the opportunities where, whether it's reserve instances, whether it's underutilized RIs, or they're unused storage environments, like the backup of your snapshots that you're taking. Are you using some kind of a life cycle mechanism so that you don't paying for those snapshots that you're not going to be using? So that helps us forecast and predict your usage and help optimize your cloud environment. And not only that, it also helps us leveraging, again, AWS machine learning, native tools and services, as well as our common cloud framework. It helps us identify any anomalies that you may have in your cloud. Have you started some 20x instances that in the development environment that you don't need? Are there any, somebody has broken into one of your accounts and started all up to all the soft limits in all regions? We have come across that as well, that one of our customers, their account was broken into, and somebody started in all regions. They started as 10x large instances in all of their, but in using our common cloud framework, we were able to identify it very quickly and then help clean up that environment and cloud environment. Similarly, so that will help us predictability of your critical workloads. That's where the cost saving is for your environment, because that's where the most of your cloud spending is. So how do we use all of these common cloud framework as well as AWS native tools? I'm going to invite Kiran to talk about AWS tools first, and then Ross is going to give you some of the specifics of some the case studies for cost saving using both common cloud framework as well as AWS native tools. Kiran?
Thank you.
That's the clicker.
Awesome. Thank you, Imran. Can you guys hear me in the back? Awesome. So I was explaining it to some folks yesterday that my voice has a hard time projecting. So please raise your hand and let me know at any point if what I'm saying is not making sense or if you can't hear me. So I'm here today from professional services at AWS. I'm part of the worldwide public sector federal civilian team. And my role generally is to work with customers to solve problems regarding AI, ML, data analytics, and anything to do with their cloud migration approach. So what I'm going to do in the next 5 to 10 minutes of your time is talk to you about machine learning at Amazon. What are our services? What can you expect from those services? And how I'm going to pass it on to send it to Ross to talk about how ECS is using these services for their common use cases that they're seeing during their common cloud framework and approach. So what is our mission at AWS? We've been using machine learning for some time now at Amazon. We have great experience. We're highly expert, a lot of expertise there that we are using and implementing in our machine learning services side. The basic construct behind all of this is to make machine learning accessible and make it simplified enough for anybody to start using and developing their own applications, their own services, and integrating them in their existing applications as well. So putting machine learning in the hands of every developer, that's what our mission is. This is the Amazon machine learning stack. The 3 layers: AI services, machine learning services, ML frameworks, and the infrastructure. The bottom layer is the one that we expect is something that the machine learning expert practitioners to need. Someone who wants to develop, build, train, do their modeling on their own. We provide the infrastructure, different EC2 instances to help them in that journey. The second, or the middle layer, the ML services layer, is the layer that kind of makes the life of those data scientists and machine learning practitioners easy, because it's giving the right tools. It's making that building, deploying, the training of the models much easier for them. And it's making it easy for them to scale their algorithms, everything. The AI services, which is the topmost layer, this is the layer where the least amount of experience is needed. Our purpose here is to make sure that anybody, any developer, can start developing, creating AI services, integrating them in their existing or old applications. As of 2019, April 2019, we have 11 services in this particular bucket. And we call it the AI services bucket because AI to a lot of people means human cognition. This is the closest to human cognition that we can get. And we have vision, speech, language, chatbots, forecasting, and recommendations that are available with this stack. A stack that anybody can start using out of the box tomorrow or today. So one of the services that I wanted to just talk a little bit more about is Amazon Comprehend. And the reason why I picked this service is because Ross later on is going to talk about how ECS is using Comprehend for a couple of use cases, like sentiment analysis. So Comprehend is a natural language processing service that helps you find insights from your text. It helps find sentiment, whether it's positive, negative, mixed, neutral. What does that text carry? Entity extraction, places, people, contacts, location. That kind of extraction from your data can be done with entity extraction. Languages. We, at this point, if I'm not wrong, we have around 100 languages supported that we can detect in a text. Key phrases. What are the key phrases that are popping up? What is the construct behind the data that you're reading? Topic modeling, something very close to me because I've been working a lot with my customers on topic modeling. With topic modeling, you can find the relevant topics and terms that are in that text. When you have medical data, when you have documents that consists of petabyte scale data that you have to manually go through, that's when you realize that finding common topics becomes a pain. When you have news articles, finding the themes from them is something that topic modeling greatly helps. So this is a place where we are seeing a lot of advancement with our customers that want to use Comprehend for various things, because they're saving not only time, they're saving cost, they're saving resources. The middle layer, the machine learning services layer, which consists of Amazon SageMaker. Who here has not heard about Amazon SageMaker? Okay, so Amazon SageMaker is a fully managed machine learning service that AWS is providing for making or building, deploying, training the models easier, faster, scalable. And with Amazon SageMaker, under that bucket, we've got Ground Truth, Neo, all of these new features that came out last year. With Ground Truth, you can start labeling your data at a much faster pace. Again, cost reduction. There's 70% cost reduction with using Ground Truth for labeling your training set. So what does SageMaker consist of? Yes, it helps us build our models faster, easily, but it also provides that performance that is not available in other sources. And the reason why I bring that up is because out of the box, we are getting a lot of algorithms that are 10 times faster in performance than on any other platform. And this is because they are already pre-trained, pre-coached to work with the best infrastructure, and they can scale based on the needs of the development as it's going for that particular model. Training your model, one-click training and tuning. I mean, all the expert machine learning practitioners or to-be practitioners who have been used to doing training, they realize how time-consuming it can be. It's an iterative process. You keep going back and forth before you can actually get to a point where you're ready to deploy your model. So using SageMaker to train is something that's very easy and scalable because the infrastructure underneath SageMaker is growing up and down based on your needs. And you're paying for what you're using. Deploying, one-click deployment. Deployment to our production systems, much easier to manage. We're using Jupyter notebooks within SageMaker to create our models. So I'm going to hand it over to Ross to talk about how ECS is using these services within their portfolio.
Thank you, Karen. Hello, everybody. Ross Serino, Director of Cloud Transformation with ECS. Thanks to everybody for giving a great intro on this. And now I wanted to dive into what we're really doing to solve some of these challenges. We wanted to frame this in the sense of we see the same thing everywhere we go, and it doesn't matter if it's the government or commercial customers, we see the same challenges everywhere. And this platform that we've been talking about really started 5 or 6 years ago. And the first build of this was actually a .NET desktop application for our billing team for them to download detailed billing records for S3. because it was too complex at that time to try to walk our accounting team through logging into the AWS console and then going to S3 and pulling files. So that was the genesis of this platform. And at that time, when we were working with the APIs, one of the things that we had brought up was, why do we have a database? You know, we were a .NET development shop. We used .NET Entity Framework, SQL Server. We're very used to, building systems with databases. And one of the first questions that I asked back then was, why is S3 just not our database? And there were lots of answers back then as to why, but now it is. What we've done is we've taken the power of AWS that we've been outlining, and we're now able to talk about data in a very loose sense. So data no longer means records in a database to us. It means files that are sitting in S3. And we've really followed the lead on Amazon on this, and I would say it started with CloudTrail, where when we talked about now that you're transformed into the cloud, you have data for free, so to speak, that Amazon is generating for you. And I bring up CloudTrail first and foremost because if you've ever seen CloudTrail logs in S3, they're almost incomprehensible to actually open up and digest. And yes, there's a CloudTrail console, but what if you need more history? And that's where Amazon Athena comes in. So when we say here that we are now data warehousing into S3 and analyzing with Amazon Athena, I like to tie in that use case of query your CloudTrail logs with Amazon Athena. If you've never done it, it's very easy. There's a blog post that walks you through exactly how to run a create external table statement in Athena, and you can query your full history of CloudTrail logs. And by the way, it works if you aggregate multiple accounts just by the nature of how Amazon is storing data in S3. The other data you get for free are things like ALB logs, NLB logs, VPC flow logs. This is all data that's just objects in S3. And it can be a CSV file, it can be a log that you read with regular expressions, but we've really started leveraging that as our platform, and we've become less focused on writing things like .NET code, and we're now more focused on answering the questions the customers ask us. To give you a visual of what I'm describing, we basically have various data sources, and just to make it simple, we're calling it CSV files in this architecture. So when we gather analytics about an environment, we'll gather that information from AWS APIs, above and beyond some of that data that I was referring to. And through that, we're able to data warehouse all of that into S3. And no matter what format it is, as long as we can create a schema in Athena based on it, we can then prepare that data for machine learning. And the number one challenge that we have when we work with customers on ML use cases is working through their data. What is your data? Where is your data? How is your data collected? What rate is your new data coming in? And then you open up a whole new area of exploration depending on whether streams are necessary for processing, or can your processing be done in batch. But it involves understanding and visualizing your data. Here's an example of visualizing data. So this is a AWS bill for one of our customers that experiences what can be called seasonality. And what will happen is with certain use cases, certain days of the week, months, have increased load compared to other times, which makes your cost very variable. So this particular customer was in the education space, and during examination time, costs go up. When you try to digest what's happening, it gets very hard because this is a worldwide application. The Australian summer is different than the US summer, and everything's in flux because new customers are coming on and old customers are leaving, and it's all over the place. So the model that we have that has statistical model under it is a visualization we had done in Excel and then tried to do curve fitting in Excel. And you can certainly make more advanced statistical models than Excel offers, but I'm just trying to illustrate when you try to use just statistical averages, you're going to end up with some kind of curve that doesn't follow your data. When you use algorithms, your learning follows your data. So when you see those two lines there, that is a prediction on the same data set from Amazon SageMaker with the actual line in blue and our prediction in orange. So we try to visualize this data to say, yes, you have a machine learning problem. We try to educate people to say, this is what we want to actually tackle, because our customer's question was, what will my annual spend be? And to calculate annual spend, we realized we had to go down the rabbit hole very, very deep. And by developing models like this, you can get much more insight into what all of this looks like. And now you see services that Amazon's producing, like Amazon Forecast. And now the same analytics that we were running on SageMaker is going to be available to everybody as a service. So what we do at ECS, when Amazon develops these new capabilities, we don't try to compete with them or fight them. We absorb those benefits and those new technologies into our approach. Because our approach is customer-centric to benefit the questions and the needs that our customers have. Now I'm going to get a little bit deeper into some of those things that we've worked with for customers. And one of those first challenges is predictive spend. So I want to show you that visualization first, that you can all understand what it is our customer was trying to do. And basically, this customer has over 80 AWS accounts, and various products have different seasonality. And they wanted analysis for both the entire portfolio as well as giving them insights at the lowest level based on how this customer structures themselves. So when we talked about the Common Cloud Framework earlier that Imran was referring to, and he said, when we talk to customers about account management, we really want to understand what are you doing with your accounts, because then we can tie those things into models to then say, your finance department is spending this much, which may be 10 AWS accounts. It may be 1 AWS account. It doesn't matter, because we try to abstract that to then make it easy. Going back to that theme of where is the easy button. So to do this, we leverage that technology that I had been referring to with Amazon SageMaker and Athena analyzing detailed billing to support the advanced forecasting and prediction model for these monthly costs. And the benefit that we realized by running this analysis is we purchased over $10 million in reserved instances on EC2, because we were confident based on these workloads that these investments would be worth it. And this involved the analytics that we did, as well as working directly with the teams that were owning the applications running on this infrastructure to validate these large purchases. We see over 25% increased accuracy on our forecasting and prediction once we move to an ML-based as compared to just that statistical curve or line that we were trying to follow. And we take all of these things together to give both executive-level insights that let them plan out, how do you spend $75 million over 5 years, as well as detailed individual analysis for developers so that we can share with them, you had a really increased spike at this time, and typically when you spike like that, you come down. But this time you spiked and you didn't come down as much as you usually did. Why? And with some of our customers, we found that things didn't get cleaned up. Automation happened to fail. Well, this is what it was supposed to do, but it didn't. And when we talk about anomaly detection, that's the type of anomaly that we're referring to. These machine learning use cases don't have to be overly complex. This is your day-to-day business, and we're just talking about using algorithms to greater answer your questions. And then the final thing that we had done with this customer is the way that RIs work are based on regions, and we had developed a very comprehensive strategy on how they can forecast and map across their entire portfolio based on region, and then they can also do global prediction based on an individual product. So with that, we find that as you expand your scope in AWS, it becomes more and more important to have a very clear governance model in place up front. And the reason for that is if you have a good governance place in place, you know what normal looks like. So if at some point things were normal, that can be your baseline. So it's very important to have that establishment of here's what normal looks like. But when you start then deviating from normal is when we get anomaly detection. So this is somewhat related to that previous use case, but the question our customer asked us is, the $1 million that we just spent on RDS, was that a good investment? Because they weren't sure how to think about cloud. So this customer was very used to buying hardware. They're very used to making capital investments and amortizing costs over time for hardware that they buy. And when we shifted this to AWS, EC2 made sense. But when you look at something like RDS and you say, I just spent $1 million on databases, did I get a great deal or did I get ripped off? I mean, from a CFO perspective, they just see the $1 million. And what we're able to do through our analysis is verify, based on your small scale compared to your large scale and compared to our other customers, you're not spending too much on RDS. You are spending about how much you should have. And then that allowed us to establish that baseline. So now all of our other purchases that we make, we're looking at these things to make sure that it is a valid purchase. And then we look at other metrics like utilization, coverage, and we're constantly tracking these things and then looking at our predictions and models and course correcting as necessary. But the only way that we can course correct based on our analysis is if we have that clear governance structure set up at the beginning. Because when you look at something like purchasing RIs or utilizing new services, you have to really understand what it is you're working with. And you have to be very deliberate in those changes that you're making. Two more use cases that I want to get through. We had talked a lot about the financials of all of this, but we do also want to highlight you can look at more than just linear data. So a lot of our early models were based on time series data. So anything that's time series data, we have an approach to model, learn, and predict. But to take it beyond just time series data like billing, everybody has web server logs. Whether you're getting those from ALB logs or whether they're Apache or IIS, everybody has logs. And one of the questions we're seeing more and more people ask is, was there malicious activity being attempted against my web server? And there's a lot of advanced products that try to answer that question. But in the most basic sense, if you just look at your logs, you might find something. And if anybody sees in their logs n parenthesis space union space select, you probably want to block that traffic. And if you've never looked at your logs to be able to say, hey, these URLs look very different than every other request everybody asks for, you might find some surprises if you start looking at your data. Because people that click on your UI happen to follow a very predictable pattern when you look at your logs. And the people that are not actually using your user interface but are manipulating URLs will stick out like a sore thumb if you start actually visualizing or modeling your data. And above and beyond using SageMaker and Athena, you can just look at this data, flag this data, train on this data, and then start getting reports around these URL headers don't match what we're used to seeing. And then you can look at the IPs that it came from, and it's like, oh, well, this is a foreign nation state. We should probably block them. And if you have something like Amazon WAF in place, you can now take that intelligence and then turn it into rules so that your server never even sees that traffic if it starts matching those patterns. But you're not going to be blocking out legitimate traffic because we've already incorporated that into the model that we're looking at. Oh, and the benefit that we had achieved on that was over 90% detection of some of those anomalous activities. And like I said, some of those do, they very much stick out like a sore thumb. So that was a lot about SageMaker, a lot about training, a lot about some of the analytics that we do to do what we do. But when we look at services like Comprehend, and I'm going to highlight Comprehend in particular, there's no reason that everybody doesn't just use this service. Besides this customer use case that I'm going to dive into, I actually used Comprehend earlier this year for performance reviews. I took emails that I had exchanged with my colleagues and processed them through Comprehend to see what it was we were doing in the first quarter, because 3 weeks into the second quarter, I couldn't remember the first quarter. And through one of the topic modeling exercises that I did, I found that we had worked on an RFI that I had completely forgotten about and wrote up a recommendation and a kudos to one of my colleagues for supporting that RFI. And when I mentioned it to him, he said, I forgot about that RFI. And it was very, very joyful getting that type of insight by going through that, because I wanted to read all of my old emails. But I said, I don't have time to do that based on how busy I am. Isn't there some kind of thing that can read all this for me? That's Comprehend. So what we had done with our customer was around support cases. So what our customer asked us was, what is it in my support case data that I should care about? Just to oversimplify what they were asking for. What are all of these support cases being opened for? And this analytics covered both AWS support cases as well as internal support cases that were in service now. One of the challenges was getting all of that data prepped to be able to be analyzed by Comprehend. But we followed our standard process of how we prepare data. And once Athena could see our data, we knew Comprehend could. And what we did by going through this Comprehend analysis was topic model all of the discussions that have been going through support cases. And we learned that 2 teams were having the same issues with RDS, and neither of them knew they were working on the same problem. And it's very interesting when you start seeing this. As long as you can understand the data that you're feeding into these algorithms, they will give you some very useful insight just out of the box, just in the report that it natively generates. And the other thing that we had done was look into sentiment around our support cases, because one of our customers had a concern that teams were potentially being less than professional. And we were curious if that had actually trickled into the support cases, or if there were just a few heated meetings. And when we ran the sentiment analysis, we found that while everything was overwhelmingly positive, you can also start to see neutral sentiment, which isn't necessarily negative, but certain groups, when frustrated, will change from positive sentiment to neutral sentiment in how they are asking for support. And if you start looking at that, you can find areas of concern within your organization just based on the type of language that they are using, no matter what they're talking about. But you have to understand what data you have, how to make it in a format that Amazon and these algorithms know how to read, but then you get to do the fun part, because then you're at the inference layer and you're just extracting insights from your data. And as Amazon releases more and more features around this, you're only going to have easier services to be able to find these insights. Just to recap, we wanted to highlight some of these values and benefits that we've been discussing. Move beyond statistical analysis. Algorithms are your friend. They are world-class today and very easy to use. Utilize a process where you continuously optimize so that you're always getting better. And we find that by doing this and having this governance model up front, it really just empowers everything else that comes downstream from that. Serverless is also your friend. Where possible, don't run servers, because if you don't run servers, you don't have to maintain them. And especially for managing your data warehouse. To have a completely serverless data warehouse is very, very beneficial for everybody, for any reason you might have. Even if you already have another data warehouse, still put all your data in S3, because you might want to ask something against your data. And when you start weaving all of these AWS services together, you really get the best approach for everything. And then finally, we wanted to share some lessons learned. Data prep is essential. Bad data gives bad results. If all of your data looks the same because of timestamps, your algorithm's going to say all your data looks the same because of timestamps. So you'll need a way to maybe trim that. And we have techniques and approaches that we've developed that we then load into our Common Cloud framework so that each customer we engage with gets the benefit of all the lessons learned from every other customer we've worked with. ML is a tool. It's an analysis, but you have to understand your data and what you're looking at to be able to truly make decisions based on what you see in your data. Large data is very good, and having large data that you are confident in is also very good when you're doing learning. This is no longer an ML challenge as we have AWS. This is a data challenge. Keep going back to that data theme, because where is your data, how can you access your data, and then how can you feed your data to these other services and technologies. And the same challenges that we had in traditional development exist in ML. A lot of ML is Python-based. Python 2 died, 2 years ago. Still in use in production today because so many things are dependent on Python 2. But everybody says use Python 3. Same exact developer challenges that have existed forever. And when you start looking at, petabyte scale, think something like Amazon Athena, because S3 will infinitely scale. And Amazon Athena, if configured correctly, will only query the data that's relevant for the query that you're running. So as these things grow and grow together, it doesn't matter how high you scale, you have a model in place to be able to absorb the benefits that are coming out in the future. And then finally, don't feel like you have to do deep learning out of the gate. Do shallow learning. Do something simple, just so that you can start understanding what inference looks like. Because even if you don't run your own models, if you start looking at inference from other models, you need to know what they're actually saying, or have a language to be able to ask somebody else to develop something that gives you what you're looking for. Or even if you're evaluating a COTS product for something, if you understand all of these things that go into these algorithms, and then you look at something like an F5 that's running machine learning on applications, that'll mean something. It's not just a magic black box. These are industry standard algorithms that everybody is using, and they're available to everybody with a click of a button on AWS now. And ECS is happy to help all of our customers through all of this. And with that, thank you very much. We are also on the expo floor at 7:24. If you want to keep following up with us, we'll be down at the expo hall the rest of the day. And with that, I did want to open it up for questions. On the weblog analysis, let's go back.
What are some of the things that you think can be done to improve accuracy?
So we were able to filter out over 90% of data. So we saw pretty high accuracy around our model that we had done. We had done a supervised training model. So our next level is to look at unsupervised training across this data. We actually worked based on an initial analysis of a known baseline of data, and then we did the classification of good data, bad data, and then we put together a system to feed updates to that model, and that's how we got that accuracy. But we are looking at deep learning models that wouldn't require supervised learning for that. And I mentioned the F5 because the F5 does that, and we're trying to figure out how it does it exactly. No, we have not transitioned to forecast yet. So we're excited to begin using forecast as it comes out because we've been doing all of our stuff kind of ourselves. And that's how it's been over the last 5-6 years is we'll kind of figure something out ourselves. Amazon is, for some reason, working on the same problem we are, and then they solve it at a mega global scale. And then we end up using their solution. But to solve our customers' needs, we have our internal tools that we can use as stopgaps before new features come out.
All right, thank you very much. A round of applause, please, for our speakers. Thank you.